Good morning, good afternoon, and welcome to Smartlogic's webinar, our Industry Conversations webinar. Sorry, I'm having problems with my screen here. How enterprise knowledge graphs solve today's business challenges. My name is Ann Kelly, and I'm your host and moderator today. And I have three great speakers: Jeremy Bentley, who's the CEO and founder here at Smartlogic; Dan McCreary, who's a distinguished engineer in AI with Optum; and Jans Aasman, who is the CEO at Franz. A few housekeeping items before we get started with the webinar. This webinar is in broadcast mode and all participants are muted. If you have a question, please put it in the GoToWebinar panel, which you should see on the right-hand side of your screen. Our goal is to have about a 45-minute panel discussion, and then we'll open it up for questions to the broader audience. And finally, this broadcast is being recorded, and replay information will be sent to all registrants one day following the webinar. So a little bit about how we're structuring our webinar today. I'll give each participant a couple minutes to do a brief introduction. Then we'll have the panel discussion, and as I said, at about the 45-minute mark, we'll open it up for Q&A. And with that, I'm going to have Jeremy Bentley, who is the CEO and founder here at Smartlogic, tell us a little bit about himself.
Well, thank you. Probably tell you a little bit more about Smartlogic than myself, but so with Mathieu Jonglais, who's our CTO at Smartlogic, we founded Smartlogic in 2006. Quite often you get asked, what's your founding use case? And our founding use case was, you can't ask a PDF a question. Of course, you can ask databases a question because you can poke SQL at them and I'll give you an answer. But to get the data out of any text-based artifact, you've got to read it and go through markup, manual markup. And that's done billions of times a day by billions of people. And we thought we could solve that problem, and we have. Since then, we've expanded into all types of text-based data processing, and text is everywhere. It's in documents, in the names of columns in SQL tables, in customer notes in your CRM systems, because you've probably got a few of them, voice-to-text transcripts, chatbot interactions, just to name a few. And why is it so important? Well, because text is the lifeblood of human written communication. It's messy, it's ambiguous, it's full of hidden meaning, which humans are innately good at putting into context. When I was preparing for today, I thought, well, let's see if you can find a good acronym that I think everyone will know. FDA. Do you know there are over 50 formal FDAs? Food and Drug Administration comes first. The Florida Dental Association comes second. Fuji Dream Airlines in Japan comes third. But if you're on an aircraft carrier, it means you're on flight deck assembly, and if you're in the eye of a hurricane, it's a federal disaster area. So I think these acronyms, the jargon, the specialist terminology used, and of course, it's actually the phrases and words around particular subjects which signpost which one we're talking about. And as a human being, we do that innately. We understand the context. But for machines to elicit context, we need good definitions of what we mean. And we can think of a meaning as a concept, and then so like profit, and then we've got to relate these concepts to each other. So profit is up is an idea of a related concept, you know, up or down being probably the other idea. And then the machine, in order to put these concepts to work, we need to put these authoritative definitions to work against real-world data. And then if you're going to automate that manual task of markup, that's what you need to do. And of course, that's a task performed by many people. Whenever you start to make data about data, technologists call that metadata. So it's data about data. Smartlogic are leaders, i.e. we're in the top right quadrant in Gartner's metadata management magic quadrant. We've been in that leader position for the last 4 years. We're the only company in the leadership space to take a semantic approach to metadata, a position, firstly, we're very proud of, but we are there because of the world-leading customers who make up our client base and put semantics and knowledge graphs to work for business benefit.
Thank you. And Dan, can you tell us a little bit about yourself?
Sure. I'm a solution architect background. I'm working right now at Optum Healthcare, part of United Health Group. We're one of the largest healthcare companies in the world with about 350,000 employees, about 32,000 IT people, about 3,000 people with a title of data scientist. And my job is I work in the Advanced Technology Collaborative as a solution architect. And what we do is we survey the landscape of emerging technologies. We find all of the technologies that we think are going to be growing in the next 3 to 5 years. And then we meet with our business units to try to figure out which technologies are appropriate for them to solve their business problems, and try to put together pilot projects and other things to make them more efficient, make them more agile, and have them grow market share. Lately, I have really been focusing on enterprise knowledge graphs. So this is the subset of all knowledge graphs where we're exceeding the roughly 1 billion vertices, and we do have tens of thousands of users and potentially thousands of developers, all using the same real-time graph engines. My work is really trying to combine what I call a systems thinking approach to this. So it's not just all of our use cases, but it also goes all the way down to the instruction set of every processor that's doing graph queries and what we call MPP, the massive parallel processing, so we can bind processing or the vertex so that we can do a lot of simultaneous queries. We have over 23,000 concurrent users of our systems every day, so we have a lot of things that we keep running. My focus has really been on trying to figure out value in the emerging landscape, and not just looking at systems enterprise knowledge graphs as a single technology, but as a landscape of things that are merging with AI, machine learning. Semantics is a very key piece. The whole embeddings movement is a huge process, finding similar items in the graph. And then in the next 2 to 3 years, learning about how we can do generalization. Inference is another key thing that we've learned from semantics, and abstraction. Right now, most deep learning algorithms don't do abstraction and generalization well. One of the key things of intelligence, and how we combine those together. Right, that's it for me.
Thanks. And Jans.
Okay, well, I'm a cognitive psychologist. I've been working with and on graphs for the last 35 years, I would say. I started as a psychologist modeling human driver behavior, or modeling human behavior in general, using semantic graphs and rule-based systems. And come 35 years later, I'm running a company, but still work with graphs, semantic graphs, rule-based systems, but now also we added natural language processing, machine learning, and graph neural networks. But I kind of feel that I've always been doing kind of the same thing. Then what does our company do? Well, we built a semantic graph database called AllegroGraph. And then we have a very cool visualization tool called Graph that lets you do no-code queries and well, all kinds of graph manipulation. But so we sell a product, but actually for the last several years, we've been mostly working building knowledge graphs for enterprise customers, or help customers build their own knowledge graphs, so they can do the things that they actually could never do before. And then we have one specialization in how we do our knowledge graphs. We really believe in the entity event approach, and I'm not going to explain that right now in this short time, but it's a way to really, really simplify your data in the knowledge graph, so it becomes way easier to do machine learning on your knowledge graph. And I think I'll keep it to that for now.
Okay. Okay. So, oops. Well, we didn't want to go quite that far. Okay. So with that, I'm going to kick off with the first question. So, what key trends are driving knowledge graphs? And I'm going to ask you, Dan, to kind of give us your take on it, and then of course Jeremy and Jans, pop in or have a discussion where appropriate.
Yeah, sure. I'm happy to start. I think the first trend that I always like to point out is the incredible growth in the interest of graph technologies in the last 7 years. If you go to the site DB Engines and you search on the rankings by category of database, DB Engines is an interesting site because they actually have a taxonomy of the different types of databases. They know all the words and labels with those things. They scan the web for every blog post and job posting, and then they look at the change in interest in different technologies. And if you go into the rankings categories, you see that since 2014, the curve in interest in graph technologies is just far, far exceeding all the other database technologies. So the first thing is just looking at the interest of graph. Second thing is the fact that we are struggling with the standards of a lot of the newer graph data models. We've had very robust standards on a lot of our RDF standards, but the most popular ones today are LPGs, and they don't have those standards. So one of the biggest trends is the GQL ISO standards. This is the first attempt that the ISO has actually made in standardizing this, the same people that have standardized in SQL. So that's a huge thing. Now that we have enough people using this, the hardware vendors are also starting to wake up saying, how do we optimize these graph queries? A lot of them boil down to what we call pointer hopping or memory references without using an index. We call that index-free adjacency. And companies like Intel are now building these new generation chips, their DARPA Hive project and Intel Puma, that have the potential, I'm not saying they've actually tested this yet, but the simulation potential for doing things like random walks to build embeddings at almost 1,000 times the performance of a standard Xeon processor today, Intel Xeon. So that's a huge thing. The big trend in graph machine learning called the native graph in situ, where we don't have to take the data out of our graph, putting into a GPU, run the model, and then bring the embeddings and things back. They can do that without having to move data around, which is very painful. The growth of NLP and a lot of the large language models, BERT and GPT, the ability for us to do role-based access control on the vertex level. And then the last thing is the communities, where we have a lot of conferences that are just focused on people building large enterprise knowledge graphs and focusing on not just the technology, but the storytelling. And how do we tell stories about how we can make these things more valuable? So those are the key trends. I did a blog in January 1st that kind of summarized all of those. And I think they have just a huge amount of potential ahead once we start to combine these enterprise knowledge graphs with the strong business problems. Okay, there's my trend report.
Mm-hmm.
Jeremy?
I sort of agree with you about the standards, but I think it's sorting itself out. I mean, standards keep going, don't they? And it is the community that in the end, gets, the users get fed up because they can't interoperate, and the community gets together and decides it's going to make standards. But I think W3C's made a pretty good job of coming out with a set of standards that if you're certain of it. I mean, some of the innovative graph databases chose to ignore it at the beginning, or they just didn't know about it. I think they're coming into line, and I'm talking particularly about property graphs. I mean, they're now at least wrapping themselves with RDF and the W3C standards, which are becoming fully adopted, I think. But maybe I'm wrong. I see it from my perspective, and you see a lot more vendors than just the one I see. So.
Well, but and then I have to say, so we create a semantic graph database. So the only customers that I see are obviously enterprises, that see the incredible importance of standards, right? And so that's why you kind of see that the property graphs think, oh God, yeah, there might be some truth to the fact that rule number 1 in semantics is give the same thing the same name. Yeah, I mean, that's the core of what Jeremy's business does, right? Make sure you get a taxonomy and possibly an ontology that tells you to make sure that the same thing gets the same name. And so the standard for that is a W3C standard, RDF, and you now see that the property graph databases slowly think, well, we'd better hop on that train too. So I'm really interested to see how this world will look like in about 5 years. Also because the RDF triple stores, so the graph database, is now getting RDF star and Sparkle star, right? So we now can add metadata to triples. So they're growing quickly to get to kind of in the same space, I would say.
Yeah, I think one of the things that I always watch is also the venture capital money flowing into these new companies. TigerGraph getting $110 million, Sambanova $676 million of funding. So you can follow the venture capital trail and find out which technologies are really projected to grow in the next couple of years. And I think what you find is that there's not just one option. There's several different new approaches that people are trying to take.
Yeah, and of course that's why standards are so important, because it allows you to choose one for one job and another for another, and you can happily know that your data can move about and it's not, not coming up against some kind of false barrier caused by the fact that the standards weren't there, which is always the beginning. Oh, that's good.
Okay. All right. Well, let's move on. Let's move on to our next area of discussion. I think we all agree that we see a lot of graphs. Graphs are in organizations, as Dan pointed out, they're trending. But what are the business opportunities? I mean, I think that's where we all really operate is within an organization, or in Jans, and well, in Jeremy or Jans perspective, we work with customers and clients. So what are the business opportunities that we're seeing that are being enabled by these new technologies, by graphs? And Jans, why don't you kick that off?
Well, I would say for the last 50 years, the dream of every big company has been to integrate all their data, right? So that they can analyze the data. And it never really worked. And it's starting to look like knowledge graphs are a solution to this integration problem. So every enterprise customer that we have wants to do better analytics from their data, and they now have a chance because there's this graph technology, that allows us, one, by adhering to semantics, where you give the same thing the same name. You can build separate databases, but because of that one thing, you can still easily merge them together. And so in some point, you have way more data together than you ever had before. And then there's new technologies that make it easier to do feature extraction for machine learning. It's getting more and more formal, more and more kind of a commodity, so that a data scientist doesn't have to learn all these technologies. Makes it easy to get the data out, and so suddenly you can do way better analytics than you ever could do before. So the business opportunity is by bringing the data together, you get more chances or better opportunities to do your analytics. And the other big business opportunity that I see is 360 knowledge graphs. So we work for a hospital and we build a 360 view around the patient. With in 1 second I can get all the knowledge about the patient, about whatever happened to him in the last 30 years. I have in a beautiful, simple graph that I can work with. I can do cohort selection extremely easy by getting a bunch of patients together. But we see the same thing in aviation. We see the same thing in banks, where the 360 view becomes important. Finally, you can see, because just think about it. If you wanted to do in a regular relational database, even in your enterprise data warehouse, and you say, give me everything you know about Jeremy Bentley, right? Well, theoretically, you have to go to literally every table to get your data. But once you get to this model of the 360 graph, it's extremely easy to do that. So the 360 graphs are important. And then we see, Jeremy already talked about documents, but all our work right now, a lot of our work is actually in analyzing spoken conversations, where we listen into calls between agents and customers, or in general CRM, and we analyze what people are saying. So that's really the next frontier, on top of documents. Now, what people were actually talking about. And it's a little bit different than looking at documents, because people talk really weird. And finally, business opportunity is the digital twins that I see, where in manufacturing, but even in banks, where you try to build a digital copy of the processes in the system, you know, that's called your enterprise, yeah, where you actually can do what if reasoning. What if we do that? Yeah, what are the most important links between the objects in my company, that if this goes wrong, it will affect all the other things there. So, well, I can talk endlessly about this, but let's stop at this for now.
Well, I just want to second the agreement completely that the Customer 360 is the principal use case that is driving many people to adopt enterprise knowledge graphs. It has certainly had a huge impact on our company, Optum. Our ability for call centers, rather than having to log into 15 different computer systems, that within 100 milliseconds, we have 10,000 points of every touch point we have, every claim, every benefit, every time they visit our website, every outbound email, every promotion, every net promoter score. It's all there, and it is the platform on which we build recommendation engines, next best action, all those things. And I should say that this is not our first attempt to do that. We have many, many prior projects that failed to build a Customers 360 because they simply didn't scale. The join problem was just too horrendous. And the more joins we had, the slower the response time. So we literally couldn't support 20,000 call center agents on the old technologies. But with the new enterprise graph things, we can get well under our SLAs of 1/10 of a second per screen. And that is the foundation that many of the other knowledge graph projects are being built, which is the integration use case. So 100% agree with you.
Yeah, I'm going to take a business value. I need to take a step back because I think some of the issues that we've got with the old way of working, let's call that the, you know, we can even go back as far as the hierarchical databases, which were, you know, fetch me a COBOL programmer when one needed to change a report. And that dominated, you know, computer industry for 20, 30 years. Then it was fetch me a database architect or designer when I need to change my schema. Because ultimately, I don't think business, and I'm talking about business people, I don't think they thanked us, even though there's good reasons why we ended up where we are, which was, you know, some of my data is called structured. A lot of my data is called unstructured. If you meet someone particularly pedantic, they say, oh, I don't like that definition between structured and unstructured because they're semi-structured. Well, yeah, great. But the point is, it's all in different places. And the business doesn't go, oh, you know, give me a list of all my customers who've written me a letter of complaint last week who've got a balance of more than $20,000 in their account. That is an impossible question to answer in the old way because you've got your letters of complaint sitting in what you might call your unstructured. And you've got your customer balances sitting in your structured system. And yet that's a perfectly reasonable business question that takes a lot of effort to fix and a lot of manual effort. So I'm really, the business opportunities that come out of the change that, you know, there's always a confluence of technologies that comes together to make something radically different. And I genuinely think that we have a radically transformational difference, but it's not just one technology, it's actually three have come together at the same time. Some have been around for a little longer, some are because of the computer power has got better, but the technology's got better, the algorithms have got better, the knowledge, you know, so much has come together. But I'd just say it's three general things first, and then we'll go into how that makes a difference to the world of data processing, data management. First is the whole graph database technology. It's a fundamentally different approach to what the old way of working. Let's call that relational, and let's not forget the COBOL history because that started it all off. But basically, your business has to presuppose the question. With relational, the business has to presuppose the question before it gets an answer. And you say, well, what does that mean? It means you have to think of the question first, and then you get an answer. And of course, human beings don't think of questions first to get answers, they iterate. So the whole graph, where you're not bounded by a schema, where you haven't got to worry about rows and columns, and you haven't got to presuppose that question, is so much more natural to the way business people iterate questions to get answers to solve problems. So So that's the first thing. It's a different way of dealing with data. And I think, and Dan's explained that it really is very exciting. It's been used live now for a very long time. It's been popularized by Google and Facebook, because you can't do what they do with a schema. It would be impossible to get a relational database to do what the graph databases that drive these massive social media and internet operations do. It's fundamentally impossible. So it had that transition, that technology change had to come along. The second technology, which is of course Smartlogic's technology, is the Semantic AI technology, the understanding of human language. And what are the meanings of that? What are the concepts in that? And what are the relationships between that? So that we can apply what we mean in an authoritative way. And we can't do that by hand, because that's millions of people marking out millions, trillions, petabytes of transactional data. So it's got to be done automatically. So Semantic AI, the semantic technology, is the second transformational thing, which coupled with graph gives you your knowledge graph. And then I don't think we should leave behind the whole open link data movement, which is not really a technology. It's just fantastically efficient to have all of your community of common interest, co-manage and co-maintain areas that you don't see as proprietary. So there's no way that anyone's now maintaining a separate database of geographies, because you've got geonames. Now you might keep your own private knowledge about where your plants are and things separate from that. But why? If you're a bank, you're certainly not maintaining lists of currencies anymore. Whereas before, if you look at the old way, probably every single system had a list of currencies maintained inside it. And then they had problems even getting that right, because they have 90 different trading systems with 90 different currency tables with slightly different rates. So this open link data movement, in combination with semantics, in combination with graph, actually gives us a genuine way of solving business problems in the way business thinks. And so my go-to for this is not to say actually all the old stuff is wrong. It isn't. It's very good. It's operationally embedded. It does the job. But the moment you start wanting to do investigative analytics, that ability not to be bound by schema, not to be worried about data volumes, not to be if you like, just like we do with intelligence operations, you've got a little nugget of information, put it in your graph. It may not be used for 10 months. But somebody else comes along, puts another little nugget into the graph, and then because that's there, suddenly you can investigate. So I think any investigative analytics is the business opportunity, and of course there's hundreds of them, millions of them. Every business has them. Every analyst is thinking, well, how could I make more money? Oh, well, I need to go and do this. Ask another question. Oh, have I got that? No. Okay, well, what have we got? And if every time you did that, you had to do another extract, transform, and load up another data model with a new column, it doesn't happen. So I think finally we've got a data management approach, knowledge graphs, which lines up with business thinking and the way the questions are asked and answered.
Oh, Jeremy, I agree that it is really the intersection of these technologies that's having a huge impact. I think we all agree that graph is one of the three ingredients. Natural language processing, another key leg in the stool. But I also want to challenge you that I think that machine learning is also starting to be one of the key things that we're starting to see impact our ability to do analytics and graph. And specifically, I think the graph embedding movement is starting to really pick up. And that it might not have as broad an impact of open link data. But I think embeddings allow us to quickly find out similar things. Similarity seems like a really important thing in recommendation. Right? Netflix will recommend what movie we should watch because they look for similar people like me that have similar interests, similar background, liked other similar movies, and they recommend. So I think what we're seeing is another technology, this graph embeddings, to start to help us quickly do that similarity calculation. And now we're starting to see things like FPGAs where you can compare literally hundreds of millions of things and return the 100 most similar items in 10 milliseconds. And that's a capability that we just haven't had in the past too. And we're still looking for use cases to leverage some of those new technologies also.
Yeah, I think you would have to. It's really the 4 points. I mean, there's not even a discussion about it. I mean, we see now every knowledge graph we built, there's a strong machine learning component. We just started offering graph neural networks, and I've given my first talks about it. But if I look at all the enterprise use cases we do, it's always about similarity and prediction of the next event, right? So I started initially, everything interesting alive is a series of events. Yeah, there's only a few graph or knowledge graphs that I know that are very static. It's always about series of things that happen to a customer, a patient, a plane, whatever. And so always the question is, what's going to happen next, right? And you can get somewhere with rule-based systems, but machine learning is really the way to go. Whether it's graph-based machine learning or regular old-fashioned machine learning, yeah. And again, something that probably would have come up anyway, but just machine learning on its own is absolutely kind of meaningless, right? I mean, it's great to take up some comma-separated files and do your analytics and then get a result you put on a report. Well, that's it. But when we do our analytics, we always put the results of analytics back in the database to enrich your data. That's actually, I mean, especially as a psychologist, it's really fun to see that you can now build learning systems, right? But then again, to your point, Jeremy, we use linked data all the time, everywhere. So
yes, I was hoping that Dan was going to challenge me, and we were going to have a good argument, but I don't. I agree with you. I just left it off the list, not on purpose, because we use quite a lot of it inside, Semaphore. But it's a machine learning sort of Kool-Aid is tricky to deal with, but actually used appropriately is really good. So we can talk about the Kool-Aid. I was maybe someone wants to ask questions about that, but the idea that you can just take data, pour it into a machine, and get good data out with insight is not right. That's a wish. I mean, we all want that, because that's called no effort. But actually, it's tricky, but apart from that, yes, the being able to overlay different graphs so that you can actually see and get the machine to do it, not yourself, so you can see the similarities and say, oh, correlation maybe, so whatever it is that you're asking, and have that all done naturally. I mean, naturally by a machine is just splendid.
Yeah, I think your statement that all interesting things in life are a series of events that happen at a specific point in time. I think one of the biggest failures we've seen is most of our machine learning models don't really take time into account, what we call the temporal analysis. A condition that you had last week is very different than a condition you had 2 years ago in predicting your future health and what your care path should be. So I think there's a lot of challenges understanding the role of time and the half-life of the impact of an event on the current predictive models. And I'll just say that almost all the models that we're looking at, very few of them take time into account. And that's a big challenge for the people that are doing research.
Okay.
Yes, we do a lot of compliance processing for regulated industries. And of course, actually, there's a trade-off between how much you can get the computer to do the engine to do on its own, and how much scrutiny you need to provide it. And of course, because we're in the compliance sector, you have to turn up 5 years later in front of a judge and explain why your machine gave this opinion about this set of data, whatever that data is. And you need to be able to explain it, and you need to be able to show that the machine actually will do it again 5 years later, so you get the same result. So there's verification if you're in a compliance industry, and you need to be, because you may be taking, maybe you're knocked off you're told to close all your bank accounts because you've got some suspicious activity. But if your machines are actually making that recommendation, I'm not saying they actually do the switching off, but they make the recommendation based on the data that they're looking at. Actually, your reputation's at risk if you make the wrong decision. So actually, thinking that you can just pour all your customer data into a machine and let it make its own mind up is not right, right, in that case. And the more the data quality matters, the more governance you have to put over your machine learning, over your machines that are driving these sorts of things. So and temporality is something that's very important in that regard, because you've actually got to prove it later as well. So not only do you have to look at the data and how old that data is, but you also have to know what the state of the data was and hold on to that so that you can prove it in front of somebody who wants to know at any point in the future. So I take that point. It's very useful for me.
Well, our next question is kind of a lead on, right, from the business opportunities. And I think, Dan, you've touched on it. Well, all of you have touched on it a little bit already. And with great technology comes sometimes challenges. And so what are the key challenges for today and then going forward? What are the key challenges with enterprise graphs?
Well, I'll answer the most obvious question for us is training, right? We just can't get and retain the right talent to do these things. It's such a quickly emerging field, and our biggest challenge is making sure that we can get people to stop thinking about modeling the world in a series of tables and think of the world as highly connected data. So that's our biggest challenge, is finding and retaining the right staff.
Jeremy, I know you have some thoughts on this.
I have thoughts on trying to learn from history is almost where I'm going to go to. I started one of my points. I said, in the hierarchical data world, you had to go and fetch a COBOL programmer if you wanted to make change. And I worry that all of this obsession with total machine learning, which involves the creation of training sets and the thing, actually, it's no longer fetch a COBOL programmer, it's fetch a data scientist. And the problem with data scientists is not that they aren't maths grads, but we're going, right now, if you're lucky to find the one unemployed data scientist in the whole world, right, snap them up and pay them a lot of money because there aren't many left. So and I don't think training should be the approach to that. What I think should happen is that the software, the machine, should be easy to use and understandable by the business users. So for me, in disintermediating the business from its data via a maths grad who understands data is not the right idea, because they may understand the algorithms, but they don't understand the business. They don't understand the concepts behind it. It doesn't matter. You're not a doctor and you're doing diagnosis. You're a data scientist. If you're in finance, you need to be a compliance expert and know your customer. You don't want to be, the data practice, the maths grad doesn't know about those laws, those rules, those things that have to be put into action. So I agree that training is important, but I also think the world could do with some better and easier to use software that actually the business trusts. And a lot of that comes down to, care. I mean, you always, with systems, you have to put effort in somewhere. In the old days, the effort was in creating the data and capturing it using a keyboard, and now, of course, it's building up, training sets and things like that. And in our world, though, the data is the effort goes into the creating of the knowledge model. And knowledge models are intrinsically easy to understand because you can show it, visualize it. You can use something like Jans visualization technology, you can use something like ours, and you can actually see whether that model is a good representation of the subject or it isn't, right? Now, you show that to somebody who doesn't know the subject, they go, well, I don't understand it. But you show it to an accountant about his accounting model, you go, oh yeah, that's right, or no, that's not quite right, that needs to be over there, that concept's not right. So that ease of use, I think, is something we've all got to work on. I mean, it's something we've spent a lot of effort on in Smartlogic, but as an industry, there's got to be a lot more. We don't want to disintermediate the business from its data.
So the other thing, the other thing we see is that, and it's kind of a boring topic, but it keeps us really busy, is security, right? The more mature a business is, the more they care about security. And we show them the 360 graphs and they suddenly think, wow, so I can see all of that and anyone can see all of that? And said, well, yeah, that's the whole point of it, right? and then they really get scared. So, and it doesn't matter whether it's aviation or healthcare with HIPAA, or in banks with compliance. Security is such a big issue, and so we've by now become almost like experts in anonymization, right? And but still being able to find it back, because Chinese walls. We in our company we have a special tool to protect every single fact in your database on an individual level via rules. So it's a challenge, because on the one hand the graph technology suddenly brings it all together, but the flip side is everyone can see everything right now, and that scares people. Yeah, as long as it's all in the silos, it's well, it's easy to protect, but once you bring it together, you really open up, you make it transparent. And transparency is a great thing for always only one party a part of the equation, right? The other part is always scared of it. So anyway, just bringing it up as
but the market
it's
is
a challenge.
It's already solved the problem, hasn't it? I mean, you have new security models because it's a 360 view, and so whereas in the old days you just worried about who had access to the particular silo, now you can't. Yeah. You have to worry about the data at a much lower level. Who has access to this particular piece of data?
Yeah, well, it's an interesting new challenge that has to be solved, right?
Yeah, I will totally agree with the fact that the more data you have connected, the more you have to focus on securing that to the right roles. And I think one of the biggest problems we've had with data lakes in the past is that they didn't have ability to restrict data sets down to the column level or the row level based on your role. They didn't allow you to do what we call item-based, role-based access control. I think in the future, all enterprise knowledge graphs are going to need to be able to associate read access at the vertex level based on your roles. And you may have 10 different roles, and every vertex may have it. But in a typical situation where we have maybe 1,000 hospitals in the graph, we have analysts that work at 2 of these hospitals, and they should only be able to write their queries on just their 2 hospitals. They should never be able to do anything beyond aggregate level analysis and the rest of that. So, and we can't protect this at the application level anymore, right? In the past, we can do that by saying you can only run this application. Now, individual clinics need to have their own analysts write their own queries, and those queries should only be able to touch their vertices. So it's a huge point, and it's really exacerbated by the fact that these things now have to scale to be not just one departmental project, but an enterprise class security issue.
And one more challenge. Oh, go ahead.
Sorry, I can't mention them anyway on public, but they were talking about that. You know, they've got their operational graph and they've got their security graph, and they're designing an approach to have the security graph is actually tracking all the data at the concept level in order to create, you know, to solve this problem. So I happily introduce you to them if you're interested later.
That's actually what we have at our customers. Operational graphs, right? We're really well guarded because there's way too much open, and analytics and data scientists never can get at it. And then we have analytical graphs, right, that are way better protected, anonymized, disambiguated, and all of that. Hey, but one more challenge for graph technology in companies is one that we run in all the time, and there's this weirdness. Like Dan is already completely convinced of graph technology, right, in the enterprise approach. But I see a lot of companies that think, oh my God, a knowledge graph, do I now have to boil the ocean, right, and do one big bang? And so we literally, every new project that we do starts with the POC with 6-8 weeks here, where we take some data and show the benefits, while at the same time I'm trying to convince them that they have to use the big enterprise-wide approach. So it's an interesting challenge to convince companies, enterprises, yeah, that this is the way forward, but do it in little steps. So Jeremy, you might run in that too, by the way.
Maybe the way we solve it, because graph and it's an agile data method, So you might as well take an agile approach to the project. A knowledge graph does not have to be complete before you can start using it. You can use bits of it, and you just prioritize which bits of it you use first. And ultimately, the most important business problems will get the priority for which part of the knowledge graph you build out first. And that really isn't a large amount of time. And then as you see the benefits for that particular area of high priority or high importance, the rest of the other businesses go, oh gosh, I've got a couple of problems like this. Why don't we'll agile those? We'll take a Scrum approach to the knowledge graph build. And so it becomes really nice drips of value. And without sacrifice, because it used to be that that was the way, but then you ended up with a silo. But because you've got a new data structure, and you've also got these wonderful things called, knowledge models, you're not introducing more silos just because you're doing things in many small drips as opposed to one big flood. And of course, the nice thing about that is both time and money, because you can put the time in, small amount of time, do a litmus test on how much money you made or saved, and then you decide how you're going to go on to the next one. And that happens much faster than the whole big bang approach of first we've got to skin up a database, then we've got to go and find the data, then we've got to spend $1 million doing this, then we've got it's so much more closer to how business likes to see things happen, which I guess is my theme for the day.
Well, it's interesting. Our first question is just another step off of the challenges. And our first question is, how does governance play into knowledge graph challenges?
Oh,
Don't all speak at once.
No, I can answer. I just don't want to take over the. I don't want to take all the oxygen.
Well, I'll state that our analysis shows that data governance is in fact more important in knowledge graphs than other technologies because we have so much data that needs to fit together correctly. And data governance and data quality are super critical. And what's really so important about this is that relationship quality isn't something that I think has been under appreciated in the past. And so how we make connections between things, this whole idea of entity resolution algorithms, so that we can make predictions of when two different representations of the person are in fact the same representation. Those algorithms are even more important than ever. So it exacerbates the problem. It means that we need better data stewardship, better definitions, precise, concise, distinct definitions that are separated from business rules for all the data elements coming in. And we are starting to just getting our handles on how to use machine learning to look for patterns of data quality. So you see a certain statistical distribution of dates of your internal known data. Somebody wants to import an external element, but it has a different statistical distribution of dates. Maybe it's many dates are Monday through Friday in the system, and they're bringing in dates that have weekend dates, but they don't necessarily make sense. So trying to use AI and machine learning to do data quality analysis as we do bulk imports is another emerging area. And I think data governance is still as more important than ever in the knowledge graph world.
So one of the things we see is that, for example, in our healthcare knowledge graph, big hospital in the New York area, that 75% of the data is basically data that points back to where the data came from. So we literally, so that's also a big price you pay, of course, that 75% of all the facts in your database are governance triples. But it's so important that we have to live with it, right? The other thing for data governance is what we see. So people talk about data fabrics. And I think that every mature data fabric actually begins with a digital asset knowledge graph that knows every silo you're ever going to need. For every silo, the table, the columns, and have a full description of this database, and not only about the contents, but even about the business lines that own that particular data set and the people using it, maintaining it, dependencies on applications, etc. So we see for the mature enterprises that they are building digital assets, yeah, because that will make data governance way, way better than you ever could do before. So yet another topic that we could talk about for an hour, but
That's a totally different.
Yes, I mean, if we'd had a different title of the webinar, I could have introduced Smartlogic in as, data governance, metadata governance, data quality, because that's really much of the output of what that's what the authoritative structure, otherwise known as a knowledge model, imposes on the rest of the data world. So, because if you structure up your governance model right, and you've got, you can do a lot of it without having to actually, through software, through machines. But what you've got to do up front is get the model right. Now, that is not a machine activity. That is a human activity. That is a expert activity, in the sense that it's a business, some data expert who understands where the systems are, where the lineage is back to where the data comes from, all that sort of stuff. It's a massive subject on its own right, but it's much more important. The moment you break open, if you remove the effect of silos, because that's the promise of knowledge graphs, and that it's delivering that promise, then governance becomes to the fore. Whereas if you had a little departmental silo somewhere, maybe data governance wasn't the top priority because you just got on with it. Now you've got a really fantastically valuable enterprise resource called your knowledge graph, and therefore governance and all that comes that imply with it comes with it. And it's got to be driven by the experts, the business experts, put in place by the information experts, but actually ultimately applied by an automatic system, because otherwise there's so much data you can't govern it. So it has to be automated. That's very important.
So we have a question here, and I'll answer. I'll take this one. It says, Dan mentioned a January blog post. Could we get a link, please? So there is a slide on the end of this presentation, which we will send out with the replay, that contains a link to Dan's blog. So you will be able to get it there. Another question: How do you combine graphs with GPT-X, for example? I think is that a Dan? I think that's a Dan question.
I'm going to jump up on this one because I'm all over this. GPT is generative pre-trained models that have become very popular in the press as far as being one of the first evidence of generalized AI. I was one of the very first people to get keys to that, and I introduced a curriculum internally so that we could teach GPT to all of our analysts. But one of the things I just really want to emphasize is that it's really not part of a production type system that you'd ever want to do these things. It is much more as a cognitive agent for people that are building ontologies and taxonomies to suggest things. So for example, in the Smartlogic ontology editor, we have this right side panel that always suggests things. GPT is an ideal example of how we could extend that to have similar things and things. But one of the constraints is that it has really been overhyped quite a bit. It has been overhyped because it has been able to solve so many NLP problems in a single model, and that just by changing the prompt, there's a new field called prompt engineering, where you effectively give it a little bit of example of what you're looking for and it fills it in. That's fascinating because there's a lot of people that are predicting that prompt engineering is going to be an entire field of AI. But I think what we see is that the number of actual use cases outside of the creative writing field is pretty small, but it is a very good cognitive assistant when you have a list of things to say, have you also thought about these things? And I've also used it to generate curriculum for STEM classes, very interesting use cases there. But once again, spending $5 million to build every machine model is a little bit out of range of most academic institutions. So we'll certainly need to focus on cost reduction things to make the machine learning process lower cost. All right, anybody else want to chip in there?
I'm not qualified.
Okay, well, we have about 4 minutes left, and I have one additional question, and it is, what are the key take-home points for decision makers? In other words, what are the essential qualities that make sure that this great, so valuable technology doesn't disappear? And I think I'm going to let Jans, or either Jeremy or Jans, one of you kind of take the lead on that.
Well, you added a twist to your question, so maybe can you do it one more time?
Sure.
You
What are
turned
the
it suddenly into 2 questions, and so you.
Well, I'm kind of combining 2 questions. What are the key
Okay.
take-home points for decision makers? And within that question, what are the essential qualities, right? That make sure that this technology is here to stay.
Well, the take-home point is that you really don't have to. So your engineers in your for decision makers, well,
Yeah.
beginning with your engineers already want to play with graphs, yeah. So that's simple, right? So it's more important that you find some low-hanging fruit where you can do a POC, right? That shows the value to other decision makers in your company. That is literally the only step forward. Because if you come with this big PowerPoint presentation about, hey, we've got to go knowledge graph, well, you have to do that anyway, but it's hard to convince them. So you have to start with little trials. And so that's what we see all the time. And then why doesn't it go away? Well, the market will always go to more and more flexibility. And I think that graph technology is the way most flexible technology right now for storing and analyzing and querying data. So we'll never go back to data that makes it harder to query, that is less flexible, right? I mean, if the technology permits.
I was a bit worried about the word disappear. So I assumed you meant disappear from your own organization, because the technology is here to stay and it's just getting better and better and better.
I know, but I mean, so the technology will never go away anymore, because all the technology around it is getting stronger and better, like Dan talked about. And it just gives you more flexibility, and that's what everyone always will go for. So anyway, that's my 2 cents here.
Yeah, I wasn't. My point being is that customers who implement a knowledge graph effectively, some of our customers, I got the phrase from one of them in particular. They said, Jeremy, we've just implemented our first 10-10 project. I said, oh, what do you mean by a 10-10 project? They said, well, it costs us 10% of the money that it would have done the old way, and it costs us 10% of the time than it would have done the old way. And we're answering questions. The business is getting answer to questions that they've never been able to ask and get answered before, because it was too expensive. So that means, okay, we've got to be successful within our organization to introduce the technology correctly. And of course, that depends on the culture of the organization. Some organizations are more forward thinking than others. So sometimes you might want to start very small, but find a problem that is difficult to answer. But that's because the data is in different, too many different places to actually bring it all together, maybe. But I wouldn't try and boil the ocean. You start small, as Jan says, proves the concept with a question. Talk to your, talk to us about whether we think it's a problem that's sensible. Talk to your business about whether you think the question is worth solving. They'll know whether it's valuable or not. And the combination of the advice you get from the business demand and your own, technology partnerships, software partnerships, and your consultants and your internal specialists that you'll likely have, you'll find you will have no shortage of problems to solve if you talk to the business, because they're filled with problems. They've got so much that they want to do, innovate, cut costs, make things better, and stop themselves going to jail. All sorts of things that just are the normal business drivers. That's a compliance problem. If you don't do it right, you go to jail, right? So I think, use your network, and your network can include us and your internal team and your business users, and then deal with it like a normal project, but not like an old top-down waterfall thing. It's an agile project, and you'll get there. But the technology itself, big companies now are built getting competitive advantage through knowledge graphs. and they don't want too many other people to know about it because it's making them competitive. But they will know about it. We'll democratize it over time.
You know, I know we're at the top of the hour and we still didn't have a chance to talk about explainable AI, which is, I think, one of our biggest things that we want to talk about. But
a whole nother webinar.
Whole nother webinar. So stay tuned.
Okay, well, as Dan pointed out, we are at the top of the hour. I want to thank everyone for joining us today, and for our great panelists, Dan, Jans, and Jeremy. Thank you for spending your time and sharing your knowledge and expertise. I hope everyone enjoyed the webinar, and you will be getting the replay back sometime tomorrow. Thanks, and have a great day.
All right.
Thank
Okay. Bye-bye.
Thank you so much to everyone who attended. It's greatly appreciated. Thank you.